Alright everybody, what is going on? Got another video here for you. This is a exponential decay problem. The Dead Sea Scrolls. So let's find out how old they are. Alright, so there's two parts here. We got part A and B. Part A, we're going to find the model for the age of the Dead Sea Scrolls, and then part B, we're gonna find the age of them. So part A says use the fact that 5,752 years, a given amount of carbon-14 will have decayed to half the original amount to find the exponential decay model for carbon-14. So basically what they're telling us there is that the half-life of carbon-14 is 5,715 years. So whatever your original amount is that you started with, after 5,715 years, you'll have half of that. All right, so let's go ahead and find the exponential decay model for carbon-14. All right, so we're going to use A equals A naught times E to the KT. Now, if we take the 5,715 and plug it in for T, that means we have half of the original amount. And the original amount is this A naught right here. That's the original amount. So if we take A naught E to the K times 5,715, so I replace the T with 5,715, and that should equal half of the original amount. So that's half of A naught. All right. Now, if we divide both sides, let's see, let's get a different color here. So if we divide both sides by A naught, we end up with 1/2 equals, and see these cancel out, E to the 5,715K. I just wrote the number before the K, that's all. And now what we need to do here is we need to solve for K. So to do that, we're going to take the natural log of both sides, and that's going to equal natural log of E to the 5715K. And so that's going to give me the natural log of 1/2 is equal to 5,715K. Now, where did this come from? Well, remember, there's a property that says the log of b to the x with base b is equal to x. If the base of the log and the base of the exponent are the same, your answer is just your exponent. And remember, this natural log e to the 5,715K, remember, natural log is the same thing as log base e. And, well, what did I do there? Hang on. All right, don't know what happened. Hit something with my hand, so I had to fix the screen. All right, so where was I? So the log with base e, we just abbreviated it using natural log. So this right here is the same thing as log base e, e to the 5715K. And see, since this e and this e are the same, your answer is just your exponent. That's where that comes from. And so then we divide both sides by 5,715, and we end up with K is equal to, so those cancel, we're left with K equals, and I'm going to write this on this side, -0.000121T. These are zeros right here. All right. So now what I'm going to do is I'm going to take this value I got for K, and I'm going to plug it back into the model that I started with. And so that's going to be A equals A naught e to the negative 0.000121 t. So that's my model there. All right, so let's read what part B says. This is your answer to part A right here. All right. All right, so now let's start part B. All right, so in 1947, earthenware jars containing what are known as the Dead Sea Scrolls were found by a herdsman. Analysis indicated that the scroll wrapping contained 76% of their original carbon-14. Estimate the age of the Dead Sea Scrolls. So when they found them in 1947, it had 76% of their original carbon-14. All right. So the original carbon-14, that's A0. That's the original amount. And what did it have when they found it? 76% of the original amount. So that's the 0.76 times the original amount is equal to A0 e to the negative 0.000121 t. All right. So what do I need to do? Well, let's go back up here first. So remember, if I take 5,715 years, that's t, and I plug it in for t, that gives me half of A0. Well, I know that for this, I have 76% of the original amount, and I want to figure out what t needs to be. All right. So I'm going to solve this thing for t. So once again, we're going to divide both sides by A0 and see the A0s, they'll cancel. And so I'm left with 0.76 equals e to the negative 0.000121 t. And so now I take the natural log of both sides. And so that's going to give me 0.76 is equal to negative 0.000121 t. I'm sorry, natural log of 0.76. And remember, natural log of e raised to this power is just that power, just that exponent. I explained how we got that right here. All right. And then I divide both sides by this number. Let's do that. Negative 0.000121, negative 0.000121. And you can see those cancel there. I'm going to write the t over here. So t is natural log of 0.76 over negative 0.000121. And so t is equal to, and when you punch that into your calculator, you get a decimal, but let's round it. So that's 2,268 years. All right. So how old are the Dead Sea Scrolls? Well, to get that, all right, it's the 2,268 years. Okay, that's how old they were in 1947. Okay, because see, in 1947, that's when it had 76% of their original carbon-14. So the age of them is 2,268 years plus however many years it is from 1947 to the current year. Okay. And when I'm filming this video, it's 2022 minus 1947, which is 75 years. So we would have to add 75 years to that. So let's see, 2, 6, 8. So 2,343 years old. That's to 2022. Okay. So that's an estimate. Okay. That's an estimate about how old they are. So, you know, if you're watching this video later on, use the current year that you're in to figure out how old they are. But I thought this was just something different. So I hope you enjoyed it. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I'll see y'all in the next one. Later.